Hi everyone. Today we have have here this question, and we are going to solve for Fourier series. Okay, so let me start. Okay, find the Fourier series for the periodic function below. This is a function, so the first thing we have to do is just write the function as it is in a Fourier series. A by 2 plus an. This goes to this one, infinite. This goes off n pi x upon L plus bn, and this guy goes to infinite as 1. And this one will be sinus of n pi x L. Yeah, just first let us find what is a0. A0 here will be 1 upon L, and here we know this is c plus 2L and c f of x dx. Again, 1 upon L, then c plus 2L and c f of x cos of n pi x upon L dx. Now for bn, you'll get the same, okay, c plus 2L, c, and f of x, then sinus, okay, sinus of n pi x upon L dx. So the first thing we have to do is just to find, okay, what is L? So L here, see, just compare this one. Just compare 0 and 2 pi, okay? This must be equal to c and c plus 2 L. Now from here, you will get what? C is 0. So if c is 0, it means that c plus 2L is equal to 2 pi. So 0 plus 2L is equal to 2 pi. Then L will be equal to pi. Now that I have found what is L, let's go to find what is directly A0. So A0 will be the integration of 1 upon pi, and it will be 2 pi to 0, and f of x. What is f of x? It is pi minus x upon 2, and this is dx. So now here directly we can just integrate this one. This will be pi, okay, pi by 2 x minus x squared by 4. This is between 2 pi and this one. So this is 1 by pi, okay, 1 by pi. Now what we are going to have here, we have 2 pi square minus 4 pi by square. And here it is 2, and here it is 4. If you just add these two, it will be 0 directly, because 2, 2, okay, 4, 4, pi minus pi, 0. Then we know that A0 is 0. Now let us find what will be our AN. So AN will be equal, we got for 1 upon pi, integration from 2 pi to 0, then it will be pi minus x upon 2, then cos, okay, cos of nx dx. Why nx? Because here it should be cos of n pi x. By here L is pi, so nx only. Now from here, what do we have to do? From here, just apply the general formula. Px here, it is pi minus x upon 2. Derive this one, you get minus 1 by 2. Then integrate this one, cos of nx dx. This will be cos, this will be sinus nx upon n. Then integrate again, will be minus cosinus nx upon n squared. Then just link this and this, and this and this. This will be minus, this will be plus. So it means that here I will get this and this. It will be pi minus x upon 2. And here I will get sinus of nx all upon n. Then minus minus plus, this minus minus, minus 1 by 2 cos of nx upon n squared. Okay, this is between 2 pi to 0. Okay, now what do we have to do here? Just substitute directly. So here what I will get, an will be equal to, if I substitute, suppose put here 2 pi. 2 pi here, it will be sinus of 2 pi x is 0. And here if you put 2 pi, it will be 1, because sine of 2 pi n, it is 1. So I will get minus 1 by 2, okay, upon n squared. So this minus, now I will substitute for 0. Put here 0, this will be sinus of 0 is 0. Put here 0, this will be 1, and this will be the same. So I will get minus 1 by 2, and here I will get 1 by n squared. So it means that what will be this an? This is 1 by pi, okay, 1 by pi. So this is 1 by pi, and this will be this guy, 1, 2n squared plus, okay, 1 by 2 n squared. This will be 0 directly. Okay, so an is also 0. Now let us rush for bn. Okay, bn. So now what will be our bn? Here bn will be 1 by pi, just follow the formula, 2 pi and 0 of the same pi minus x upon 2, and here sinus of an x dx. Now what we have to do, the same, p of x, it is pi minus x upon 2, and then derive, okay, it will be minus 1 by 2 only. Now integration of sinus of an x dx. This will be minus cosinus of an x upon n. Then integrate again, it will be minus sinus of an x upon n squared. Just link this and this, this and this, plus negative. Do the same, and this will be end in this. This and this will be minus here, and this will be pi minus x. Pi minus x by 2, okay, minus x by 2, and here cosinus of an x all by n. Then minus, because minus minus plus this minus 1 by 2, okay, 1 by 2, then sinus of an x upon n squared. This is 2 pi to 0. Do the same, okay, just substitute bn. When this is 2 pi, this will be 0. 2 pi, this will be 1. Okay, and this will be pi by 2. So you will get 1 by pi. It's 1 by pi. 1 by pi. So this will be pi by pi square. Pi by 2. 1 upon n. Okay? Then this is 0. For the other one, this will be minus. But see, it is minus of the formula. Now from minus and minus, this will be plus. Then all the terms here inside will be positive. So I will get this one. I will get for 0. Put here 0. Okay? Put here 0. Just put here 0. You get pi by 2. Put here 0. You get 1 by n. Okay? Then put here 0. You get 0. Minus 0. Okay? It means that bn will be 1 by pi. 1 by pi. Then here I will get pi by 2n. And here I'll get also plus pi by 2n. Now see, pi, pi, and pi. This will be only 2 upon 2n. 2 and 2. It will be 1 upon n. Means that bn is equal to 1 upon n. A0 is 0. An is 0. So, what will be the Fourier series for this one? We will get f of x is equal to a0 upon 2 plus an, okay, goes to infinite, and cosinus of an x plus bn will be this one, and sinus of an x. But here all of this is 0, so what will be then? f of x will be equal only 0, 0. So 0 upon 0, it will be 0. Okay, plus 0. Then it will be 1 upon n. This one goes to 1. This is sinus of an x. This only. So here I can write. So f of x will be equal to 1 upon n. From 1 to 0, this will be sine of an x. This is equal to sum from 1 to infinite of sinus of an x upon n. Okay, so f of x also can be written in this way. Sine for n equal to 1, this will be x plus, for n equal to 2, 2x plus equal to 3, 3x, and plus, okay, by 3, by 2, by 1. In this way, we have the Fourier series for this function f of x equal to pi minus x upon 2 in this interval here, 1 upon 2 pi. Thank you. Hope you can understand something.